This evening, we're very honored to have with us and host Mr. Peter Luckey. Mr. Luckey is a senior solutions consultant at the 321 Gang company, I guess, an Arizona-based engineering consulting firm where he offers technical leadership and advice to clients looking to improve their engineering processes. Some further background. He received his master's degree in computer science from Purdue University. Peter got involved in selling and supporting rational, now IBM tool sets and the processes supported by these tools. Mr. Luckey began his professional career at IBM's Federal Systems Division as a programmer and then became a manager of IBM's rational software development environment. Concurrently with this, Peter also worked as an adjunct associate professor at the State University of New York, Binghamton, teaching software engineering and publishing a number of papers on the subject. Mr. Luckey is a certified Scrum Master, a certified SAFe program consultant, and is also an Atlassian Jira aligned technical professional. Mr. Luckey consults on model-based systems engineering, lean, agile, and SAFe. As well as how to apply the successful implementation of a variety of the tools associated with those and in support of the various processes. So with that introduction, I now would like to turn it over to you, Mr. Luckey, to begin with your presentation.
Okay. So let's see if we can get things set up properly here. All right, so we're seeing the MBSC and SAFe for systems engineering slide.
Yes.
Correct?
Yep.
Okay. Good. All right. So systems engineers, Agile has a problem with you. It doesn't know what to do with you. Just think about it. Agile advocates small cross-functional teams that define, design, implement, and test software. So where do systems and systems engineers fit in? Well, it was not until we attempted to build systems using Agile techniques that we realized we needed to scale up these techniques and incorporate system engineering processes. So multiple frameworks have come into the limelight for scaling Agile. The most popular is the Scaled Agile Framework, SAFe. And sound the horns, model-based system engineering, MBSC, is making a resurgence. SAFe has conceptually included MBSC and a role for system engineers in its large solution configuration, but most of the implementation details have been left to the user. In this presentation, we will talk about a number of techniques that fill in these details. So hold on, the ride might get a little bumpy. So as was said, I'm Peter Luckey, a senior solutions consultant with the 321 Gang. And the gang helps organizations improve their ability to design and develop high quality systems and software. And we do this by helping them adopt the best Agile or lean or traditional practices and or tools. We are partners with the Scaled Agile Incorporated, the creators and maintainers of the Scaled Agile Framework SAFe, as well as being partners with IBM, Siemens, Polarian, and the Atlassian Jira Align. So our premise is, it is important to involve system engineering in the identification of the features to be developed during each program increment. And we'll talk a little bit about what a program increment is a little later if you're not familiar with that. So our objective is we want to use MBSE to facilitate the emergence of the requirement specification in an iterative fashion. This will allow us to identify the features to be developed in each of the program increments. The system engineers will collaboratively create a shared understanding of system structure, behavior, and interfaces, and record these as decisions as a single source of truth using standard notation, SysML. Then these emergent specifications will be used to drive the Agile development process. So today we're going to talk about a workshop that we put together for system engineers working within the scaled Agile framework. In the workshop, we make sure that the participants understand lean Agile principles, practices, and roles. And we talk about the characteristics of a specification workshop. But the majority of the workshop is about building a SysML model of the system under development. And the process for building the model is divided into two parts. The first part is analysis, and the second part is a combination of design and construction. At the end of the workshop, we talk about incorporating MBSC and these workshops into the Agile development process and discuss where system engineering fits in. So you are certainly welcome to ask questions as we go through. There will be a time towards the end that I'm going to try to get you involved in a discussion of some things, but we'll sort of play it as it goes relative to that. So if you have a burning question you want to ask, just ask and we'll see what we can do. So to work in this mode, it's really imperative that we understand lean Agile principles, practices, and roles. So let's just review them a little bit here. The lean Agile foundations are encapsulated in the House of Lean and the Agile Manifesto. The House of Lean is a classic metaphor describing the values that are essential for lean thinking and is based on the Toyota production system. At the very top of the House of Lean is, it is overarching, is the value that matters. It's the common thing we care about. Then the four pillars address respect for people and culture. So we're not trying to change old habits, rather we're trying to implement new habits. And once new winning habits are implemented, the culture will change. Then the second one is flow. Operating a product development process near full utilization is an economic disaster. This is from Don Ryerson in his book, Flow. Innovation, the third one, the third pillar. It is very important that we create free time for innovation. This need for innovation time should be included in the process. And then the final one, relentless improvement. Those who adapt fastest win. The pillars are grounded in leadership. Management needs to lead the change. They must know the way, emphasize lifelong learning. The Agile Manifesto, which is now 20 years old, suggests that we change our perspective. We want to focus on individuals and interactions over process and tools. We want to focus on working systems over comprehensive documentation. Look at customer collaboration over contract negotiation, and responding to change over following a plan. So there are 12 principles that expand on these changes. Let's mention a few here. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. Welcome changing requirements, even late in the development. Agile processes harness change for the customer's competitive advantage. And the third one we'll mention is working software is the primary measure of progress. Now, SAVE, the Scaled Agile Framework, defines a system of integrated, proven practices that have improved employment engagement, time to market solution quality, and team productivity. Because of the complexities involved, there's no off-the-shelf solution to the unique challenges each enterprise faces. Some tailoring and customization may be required, as not every safe recommended practice will apply equally in every circumstance. This is why we work hard to ensure that the safe practices are grounded in fundamentally stable principles. That way we can be confident they'll apply in most situations. And when they don't, the underlying principles will guide the teams to make sure that they are moving continuously on the path to the goal of the House of Lean, shortest sustainable lead time, and the best quality and value to people and society. There is value in that as well. So safe practices are based on 10 concepts that you see in the picture here that have evolved from Agile principles and methods, lean product development, systems thinking, and observation of successful enterprises. In the workshop, we focus on the 4 we have underlined. Apply systems thinking, assume variability and preserve options, visualize and limit work in process, reduce batch sizes and manage queue lengths. And then the 4th is apply cadence, synchronize with cross-domain planning. So let's build the organizational structure starting with the Agile team. Together, the product owner, the Scrum Master, and the other team members comprise the Agile team. We are probably all familiar with the roles, responsibilities, and processes followed by the Agile team in SAFe. Again, where do the system engineers fit in? We need to look at the scaled Agile framework to start to understand that. So first, let's examine the essential SAFe configuration before we look at the program level. Notice the Scrum and the Kanban icons associated with the Agile teams. Then we want to notice the program level in terms of roles. We have a system engineer or architect. We have a release train engineer, a product management, business owners, talked about on a later slide. We have a backlog, which is a program backlog of features. And this, you'll see, is a derivative of the specification workshop we're going to talk about. We have cadence going through the Scrum to the program increment, alignment events, PI planning, and inspect adapt workshops. We have the Agile release train. We have continuous delivery, architectural runway, a spanning palette that shows vision, roadmap, system team, supporting concepts, lean Agile mindset, and SAFe principles. And at the large solution level, we introduce some other ideas, the solution intent and the solution context, which play big in what we're doing in just a little bit. With the solution intent, we talk about variable versus fixed. We talk about compliance. We talk about MBSC, set-based development. We also have new roles, the solution architect or engineer, the solution management, solution train engineer, and the customer. And for the workshop, we're not going to go up to the portfolio level. We'll stop at the solution level. So what do we do in these workshops? The specification workshops create alignment and a shared understanding. So system engineers create and maintain the system's single source of truth within the solution intent using SysML models developed using model-based system engineering. So ideas from multiple experts are socialized. Engineering work is performed before and during each program increment. Architectures are defined incrementally. Designs emerge, recording decisions in the specifications. Features are identified to build in each of the program increments. And this is a very iterative process. So we use these system engineering workshops to create specifications and plans. Workshops elaborate the architecture and design over time. We always keep our options open, or as long as we can, elaborating detail at the appropriate time. We use model-based system engineering to identify and model course-level system behavior and structure, and define plans to realize the solution. So there are three major items that fall out of the workshops. The solution intent, which captures the system structure and behavior in the model. The development roadmap, which is the plan to incrementally realize the solution. This allows the teams to focus on near-term goals and learn as they go. The program backlog, this is an output from the workshop design activities, so it happens in an incremental fashion. The system specifications are maintained in the solution intent. The SysML model should be the single source of truth built using MBSC. The design and construction parts of the workshop identify features and enablers that should be in the backlog for the next increment of the solution. Also during the design and construction, the architectural runway is built by realizing the needed parts of the model. We need to have a series of these workshops to prepare for the next increment. So we are making these workshops part of the cadence and building the specifications during the increment ahead of the development effort. So there are 6 steps in an iteration to develop the system engineering specifications. And these steps happen during the workshops. 3 steps in analysis, 2 steps in design, and 1 step in construction. So this is the SysML and SAFe view of the process. So let's first start with analysis. So the 3 steps are define the actors and their goals. And we use use case diagrams to do that. Second step is specify behavioral flow for those goals. And we use activity diagrams for those, for specifying that behavior. Then the third step is identify interactions between the system and the environment. So here we're using sequence diagrams, the black box variety of these sequence diagrams. So once we've been through those 3 steps, we're sort of on the first iteration of analysis activities. We're going to build a roadmap showing the program or product epics on a relative timeline. Then we move into design. So we allocate behavior to the system parts using sequence diagrams. Now this time they're white box sequence diagrams, so we can see what's going on inside. Then we identify systems components and their interfaces, and we use internal block diagrams to show that. And the final step here is to move on into construction. So during construction, features and enablers are added to the backlog, and the needed architectural runway is built. So construction is based on the SysML model. Now, any of the pictures that you'll see here are drawn using we're using SysML and are maintained in the solution intent. And we use the IBM tool Rhapsody to draw these things in the pictures that you'll see. But it really doesn't matter. During the workshop, we use whiteboards and flip charts. Now that we're doing them virtually, we're using drawing tools on so that we have whiteboards that we can draw on virtually and so on. So the analysis activities are performed quite extensively before the first PI planning session, and in a more focused sense before each successive PI planning session. So again, let's look at the iteratively developed specifications, right? So analysis, all the diagrams, again, you see were built using IBM Rhapsody. During the workshop, we prefer to use the whiteboard or flip charts, capturing the final results with the tool. So we define the actors and their goals, use case diagrams, we specified behavioral flows for the goals, activity diagrams, and we identify interactions between the system and the environment using black box sequence diagrams, resulting in a roadmap of epics. So let's take a look at each of these steps a little closer. So step 1, define the actors and their goals. So just to give you a little background, these are the stakeholder needs that we use in the workshop for input into the analysis steps. And these might need to be drawn out in general from, if you're doing this for real, these might need to be drawn out from the stakeholders, or they might be provided by the stakeholders. So we also have some non-functional needs that we got from the stakeholders. You know, we can't kill anybody. We're supposed to obey the traffic laws. So during the workshop, we follow the steps outlined here to create a use case model of the system based on the stakeholder needs. Now, this is done in a team setting, drawing on whiteboards or flip charts. In the use case model, we identify the primary actor and the main goal. Okay, so you see the primary actor is here, the passenger, it might be called the driver, and the main goal is drive to a destination. We also identify secondary actors and sub-goals. And on some large systems, there might be multiple goals, multiple use cases that we are talking about that would be designated as the alpha threats. Second step, we specify behavioral flows for each of the goals. So for each main goal or alpha thread, an activity diagram is created. This activity diagram shows the top level activities going on within the primary use case. So here's the primary use case, here's the activity diagram. And then once the sub-goals are identified, we specify the behavioral flow by creating an activity diagram for each of the sub-goals as well. So here we have 3 of the sub-goals called out, and an activity diagram is created for each one of these sub-goals. Step 3, we identify the interactions between the system and the environment. So here's where we identify a primary thread through each of the activity diagrams and create a sequence diagram for each of these goals and sub-goals. And again, this is a black box, so we're just showing the major activities that are going on in the thread and how they interact with the environment. So the sequence diagram, again, depicts the thread and illustrates the interactions between the system and its environment. So after the first pass through analysis, we identify epics and build the epic roadmap. So epics are large, cross-cutting initiatives that deliver significant business value. We want to strive for minimum viable epics, small batches of value. And each activity will have many threads or epics of varying scope. So for this example, we chose the major threads through the primary activity diagram to help us identify the epochs. So the epochs would be drive to the destination. That's the primary one, the simple one. Then there's drive to the destination while staying in lane. Drive to the destination while detecting side obstacles. Drive to the destination while obeying traffic lights. And drive to the destination while detecting forward vehicle. Now, what about parking the car? Is that an epoch or is that something else? So typically on a large system, there is a main goal associated with each epoch. In the following slides, you will see there are other possibilities for the epoch breakdown and roadmap. So this shows another possibility for an epoch breakdown and roadmap. For a large system, the epochs are broken into capabilities, and the capabilities are broken into features. Each capability must fit in a solution-trained program increment, and the capabilities are broken into features such that each feature is allocated to an Agile release train and must fit in an Agile release train program increment. So for a system contained in a single art, the epochs are broken into features, and each feature must fit in an Agile release train program increment. So this illustrates only a small part of the decomposition into features, what the picture that we have here. So there are probably many more features that are here, but it just shows that each feature must fit in a program increment and stem from or be a child of one of the epochs. So we rinse and repeat. So this is why the first time through, where you are discovering the epochs so that you can build your epoch roadmap, it might take some time or a little bit longer than it will the next few times. Once you have discovered the epochs and built the roadmap, further analysis and design needs to be done for only the epochs that will be touched during the upcoming program increment. So during the upcoming PIs, the epoch backlog and the roadmap is revisited, and analysis and design are performed on the epochs that will be touched in the upcoming PI. Now, prior to the start of each program increment, we go through a review of the analysis that gave you the epochs in the roadmap, which are the focus for the upcoming PI. Then we go through the design and construction of these same epochs. So again, this is only done on the epochs that are to be touched in the upcoming program increment. So for design, we allocate the behavior to the system parts. We do a sequence diagram. This time it's a white box sequence diagram. So we're identifying what are the different parts of the system that play together. Then we identify systems components and interfaces. So we use internal block diagrams to do that. Once we've identified that, we go into the construction where we define the backlog items from the interactions. So we have a backlog of features and enablers and build the necessary architectural roadway or runway that we're going to need in the upcoming program increment. So step 4 is allocate behavior to the system parts. So the first step in design is to take the black box sequence diagrams and expand them into white box sequence diagrams. This allows us to identify the system's internal components and start to talk about the interfaces between them. Now, you can use either the sequence diagrams or activity diagrams to do this. Many system engineering groups prefer the activity diagrams because they can show multiple paths the sunny day, the exceptional, and so forth in the same view. Step 5 is identify the system components and their interfaces. So we draw simple block diagrams showing the hierarchical relationship among the components and the interfaces between these components. We could also do this by overlapping swim lanes on the top of the activity diagrams. We're just showing the internal block diagrams here. Now, this diagram focuses on the interfaces. Each interaction requires a connection and an interface. Interfaces are one way, so we use two interfaces for a bidirectional communication, using behavior to derive interface specs between the system parts. And then step 6, we define the backlog items from the interactions. So we define the backlog items from these interactions, discovering the features from groups of interactions. Some of these might be grouped in an activity. Some features may require, especially the sub-activities. So some features may require some more exploration, work yielding enablers. So we focus on requests from the UI and controller parts of the system. So this example highlights two stories that contribute to the select the optimum route feature. Also, we might identify a park car feature from one of the activities. So that's what I think we would do with park car, is turn it into a feature as opposed to an activity. So we're going to manage non-functional requirements, NFRs, and NFRs constrain the backlog items. So they are not backlog items, but they constrain the backlog items, the implementation of these backlog items. So workshops will uncover both behaviors and constraints. So we want to make sure we record the NFRs as they are found, and we most likely are going to trace them for compliance later. Enablers may be required to support these enabler features and adherence to the NFRs, and NFRs might be reflected in acceptance criteria. Okay, let's try to put this all together. But before we put this all together, let's address the requirements and test in a regulated environment with SAFe. When working in a regulated or a compliance-driven environment and the scaled Agile framework, just as it is necessary to maintain an architectural runway, it is necessary to maintain a test and requirements runway. So during each program increment, it must be demonstrated that the features covered during the current program increment are verified, as well as during each of the iterations of the PI. It must be demonstrated that the stories implemented during the iteration are verified. So the features and the stories are verified against the acceptance criteria for the features and the stories. This is primarily done by the Agile release train teams and is illustrated below the dashed line. For a release, the stakeholder requirements must be validated, the system requirements must be verified, and the software and hardware subsystem requirements are used to evaluate the subsystems. But in SAFe, this happens in an iterative and incremental fashion. The increments follow the iteration and the PI boundaries. This is illustrated above the dashed line. Now, to that extent, there will be iteration test plans per team that encapsulate the unit tests, which are based on the story acceptance criteria. There will be a program increment system test plan for each of the PIs. These are child plans of the master system test plan. The focus of the program increment system test plan is to verify the features implemented during the program increment. The key to making this a cohesive process is the architectural runway. The state of the architectural runway before the first PI planning is the analysis model. The system vision is developed based on the stakeholder needs and the business context. An analysis model is built of the system, also based on the stakeholder needs, business context, and the system vision, if it is available. The analysis model is built using use case diagrams, as we talked before, and activity diagrams. And from the analysis model, program level epics and features are derived and used to create the roadmaps. The analysis model is also used as input while deriving the system requirements from the stakeholder needs. So before the very first PI, a workshop or series of workshops are held to analyze the system, resulting in a behavioral model. Following are the steps that are gone through. So we're going to repeat what those steps are to get to the point where we are starting to identify the features and enablers to be developed during the program increment. So we develop the vision based on the stakeholder needs. We define the actors and the system goals. We specify the behavioral flow for each of the goals. We identify the interactions between the system and environment. We build the epic and corresponding feature roadmaps. And then prior to PI planning session, the system engineering team working with the PM, the system architect, the validation and compliance team, and the POs prepare for the program increment planning session. The part of the model that will be implemented during the current PI is designed. That's the architectural runway. The system requirements and the test cases are developed for the part of the system that will be built in this PI. That's the requirements and the test runways. And the features and enablers allocated to the current PI are put in a backlog and allocated to the Agile teams. Starter stories are created for these features and enablers. And then prior to each PI planning session, a workshop or series of workshops are held to review the analysis and design of the epics that will be touched during the next PI. And following are the steps to prepare for that. We allocate behavior to the system parts. We identify the components and their interfaces. We identify features and enablers for the PI backlog. We create starter stories for the PI planning. We design and build the architectural runway, and we create the test and requirements runway. All right, so that's really what we're doing. Now, in the workshop, we have a discussion regarding these activities, things that might be different from one organization to another. So let's take a look at these, and so now you go off mute and shout out what you think. So if solution is composed of one Agile release train, what roles should be involved in the following activities? So creating the use cases and the activity diagrams. Who should be creating the use cases and the activity diagrams? What roles do you think? So I'm looking for some response. So if we're going to create use cases and activity diagrams, who should be involved in creating those? What do you think?
Product owner? The product owner?
Well, definitely we want the product owner in there. Who else?
The system engineer.
Oh, of course, the system engineers. Okay, so both of those. So we need some of the expertise from the product owner. We'll probably have the lead architect or system engineer and a team of the system engineers. How about creating the black box and white box sequence diagrams?
More systems engineers.
pretty much the system engineers. How about building the epic roadmap?
That one gets a little tougher because you still need the system engineer, but you might want to start bringing in the software people that have a good handle on what's possible to do with the software.
And probably, again, you want the product owner involved with this as well, to help you identify what needs to come first, second, third, that kind of stuff. Okay. How about identifying the features for the program increment? So who, if any of you know SAFE well, who in SAFE is designated with that particular job? Identifying the features.
Scrum Master.
No, it's not the Scrum Master that identifies the features. Yeah, it's the product management. So the product owners and the product manager. Okay. Now, if we're going to involve system engineering, we probably want the system engineers, because they're the ones that know the model that we're building here, to help identify the features. Okay. And work on a daily basis on activity diagrams and with the teams on sequence and block diagrams. Now, who's going to do that one? That should be an easy answer. System engineers, right?
Right.
Right. Okay. So
A
now
system engineer with a minor in integration.
yes, definitely. Definitely. Okay. So let's go on to the next discussion, right? So if we are doing things the way we sort of talked about there, how do we want the systems engineers incorporated into the Agile release train? And we really have three different models that we could use. So we could have just a single system engineering team, and they do all the system engineering work. You know, they work in these workshops and they come up with these models and diagrams and so forth. We could embed the system engineers, break their team apart, and embed the system engineers such that there's one or two of them on each Agile team, and they work directly with the Agile team to do that. Now, they probably are parts of the workshop as well. And then there's a hybrid model where you have a system engineering team where they are in this workshop building things out, and then when they're not actively involved in working together as a team, they go and they sort of adopt an Agile team and work with them to help interpret the models, help answer questions relative to the models and the specifications, and work with them. So which do you think would be the best approach? The single system engineering team, or embedding them with the Agile team, or a hybrid model where they're doing both?
I would vote for the hybrid model because the other two have major pitfalls associated with them. On a single system engineering team, what can happen is that team can become isolated from the actual design work. And when you embed the system engineer with the Agile team, you run the risk of them going native, a technical term which means they forget their overarching SE responsibilities and they swing with the design team.
Right, right. And so if we do the hybrid model, it sort of is the best of both worlds, or it fights against those two problems. Okay. Yeah, so any other comments on that particular thing?
Yeah, I have a comment. I think, I have a little experience with this, and I think it depends on the maturity of both the software team and the system engineering team, whatever their size or orientation. Because one of the barriers getting started with something like this is getting the software people comfortable with whatever modeling is being done.
Yes.
MBSC, SysMol, or whatever is pretty much a system engineering sandbox right now, and the people who need that information and have to participate in modifying at least are the software people.
Okay. Okay. So to me, that would bode for making sure that we have some of these system engineers readily available to work with the Agile teams.
Yeah, and I would stress what you've already stressed, and that is, it's iterative, a very iterative
Yes.
process that they have to get together. They have to sort of understand the language, and then they have to be able to participate together and move the model forward.
Yes, definitely, definitely. All right. So what is the process? We collaboratively build a solution through emergent specifications and an Agile roadmap. Okay, so that's what we're trying to do. Collaboratively and iteratively build a solution through emergent specifications. Okay, what value does it provide? So you get what you want, not what you necessarily specified up front, but you get what you want because you're constantly revisiting this. Again, that's the goal of iteration and being able to change things on the fly and so forth. We're continuously aligning everyone on delivering the greatest value frequently and reliably. We explore alternatives to make the best economic decisions. Okay, so we don't make all of our decisions up front. We make them at the latest point in the process that we can. And then we adapt to new information, both external and internal to the program. And so what's our ask of the customer or business? To participate with us in regular Agile ceremonies for alignment, review, and adapt. And we need to appreciate the lean principles of cadence, synchronization, flow, work in process, adapting to new knowledge, emergent design, and taking an economic view and applying them to the traditional EVM, schedule, and cedrals, etc. Now, that last statement is huge, and it's also hard to do. So this is really where it takes management buy-in from the top all the way down through, and time to adapt. Okay, so it can't just be pushed down people's throats. It has to be again an iterative adoption process as well. Okay.
What I think, Peter, what I think is interesting about your discussion here is that one of the key characteristics of any system, particularly in the definition, is emergent behavior, is almost singly what defines a system. And you've come up with a process that creates that emergent behavior through the emergent design.
Correct, correct. I mean, that is huge in what we're doing, and that has been one of the biggest what do I say? People have fought against that are doing systems, especially that are doing systems with compliance or government regulations and so on and so forth. How do we actually do emergent design if we have to know everything up front? You know, those kinds of things. So this is a way that we can do it, and we can sell it to the government. So there are all sorts of government organizations that are starting to adopt this kind of thing, and so it's working. Okay, so let's open it up for questions, comments, concerns, whatever you would like. And we'll just take a few minutes and open it up for that.
Yeah, Peter, if I can, before questions get started, people think about the questions. Let's have 10 or 15 minutes for questions, then I'll do the raffle. And then if there's still more questions, we can hang around and chat longer.
Okay.
Anyone
So
want to start us off?
has anybody been in a situation where they've actually used SAFe and some of these things already? Have you tried some different models, or what do you think? What's your experience?
Hey, Peter, this is Dave Fadley. One comment is I do consulting work for an organization that when they do software, and it's mostly government focused with a mixture of government contractors, government folks and contractors, and they tend to get rewarded for getting something out the door rather than nothing. So they'll tend to drive through stuff, and in terms of like if 20% capability is good enough, get it out. So I don't want all this other stuff holding me back kind of attitude. So what is the drive, and the ones you've seen, what organizations, what is their driver? Is it strictly the profit making ones, just to get it outdoor, to get time to get the award fees or whatever? Or have you seen it really happening with a successful government driven, development side on using these principles?
Well, I have seen it where it does work, and I have seen it where it doesn't work at all. You see in the list of things, the F-22 advanced tactical fighter, that one actually was a positive use of SAFe and those kinds of things, and they did well. Unfortunately, I was working with I probably shouldn't say who it was, but another group down in Huntsville, Alabama, and they said they were adopting SAFe, and we talked to them about this kind of stuff with their system engineering. But when it came down to it, they were just talking about SAFe, but they were still implementing things the way they had always implemented things. And that was a disaster. If you're saying you're doing SAFe and you're doing something completely different, it actually is worse than if you were saying you were doing something different and did it. So if you are driven by the old CDRLs that the government used to have and so forth, and trying to apply SAFe, you're still going to have troubles. If you are driven by the new way the government is attacking things, using Agile and scaled Agile and so forth, and your focus on delivering value, then this works. This really works, and it delivers the incremental value that you were talking about earlier as well, so that you could really, build the minimal viable product, get that out quickly. If that's good enough, there you're done. If you're not, then you go and build the next one, and then the next one, and so forth. But you keep doing it in these increments and so forth, adding more functionality, more whatever to it. So that's sort of a long answer to your question.
Yeah, no, appreciate that. I mean, more of along a government organization is responsible for building it and developing it, and they use government employees as well as contractors to develop it, right? It's kind of a unique environment that way. But
right.
So what they tend to get rewarded for is just get it fast out the door, partial capability, and instead of having held to, yes, you have goals for increments, and they might want to use Agile and they do it, but the end game, whether it's MVP or whatever else they want to call it, those are goals, and they may or may not make them, and they're not penalized for whether they make them or not. As long as they get something out and they can improve it the next one, that's kind of how it's look. So it's kind of loose on this stuff. And therefore what happens is your system engineering view tends to get devalued a little bit because they're not really trying to hold to a certain threshold to get it out kind of thing. If that makes sense, what I'm saying.
Right. So a little bit of difference here is we're really using the system engineering view to drive the requirement specification. So the difference is we're building an incremental requirement specification. We don't have a full requirement specification at the beginning. We only have enough of the requirement specification to build the next increment. Okay, and then we're going to add to that. And we're going to add to that by building out the model in more detail, or a different section of the model. We're going to build that out and develop the model and the system specification and the test cases and all of those kind of things in this incremental fashion.
There's some questions in the chat. You see those or not?
I don't, because I'm displaying this other stuff, but
Let me ask some of the people to maybe unmute their mics. Is it Andres? Maybe I'm butchering your name there. Can you unmute yourself and maybe ask a question? Or I can read.
Well, Clinton, I'll take that on. And Andreza has asked, he is definitely interested in MBSC for the future. How can it be used effectively in product development to define the system context and features requirements? Then he goes on to say he's only used UML on an ad hoc basis.
okay. So essentially that's exactly what the talk was about, is how do you do that? Is by building out the model and building it out in an incremental fashion, and starting out by building out a high level one so that you can then start putting together your roadmap that you want to follow, and then you choose the piece of the system that you want to work on and go deeper and go into the design aspects of that. So, but we're using MBSC at each step of the way to really define that specification for what it is that we're going to build.
And then he has a follow-up question. How do you go about transitioning an organization from traditional waterfall, where everything has to be designed up front in a linear fashion, to the emergent design, as you've just briefed us on? So
I mean, there are lots of things relative to transitioning, and transitioning is a huge thing, and it normally takes an organization anywhere from to transition the organization from 18 months is really short to 3 years to do this transition, but there has to be a plan in place, and there will probably be some pilot programs that are working in this new mode, and they're going to get some quick wins, and then it sort of spreads to other organizations. There's training involved. There's and there's probably some new tooling involved that you want to get a hold to do these kinds of things. Training in the process as well as in the tools. It is a huge deal to transition from the waterfall way of doing things to doing things right in the scaled agile way of doing things, and using MBSC and so forth. And it's quite a discussion relative to the transition. So not an easy answer, not a quick answer to that one, but it's certainly something that has been done by a number of companies and so forth, and done successfully. Has also been done poorly by some. So we have a lot of lessons that we can learn from folks that didn't do well. But you can get there today.
And Stephen Sutton has submitted a question. Stephen, if you're out there, you can ask it, or I'll ask it for you. Stephen wants to know, does the process apply to defining and designing the combination of hardware and software?
Yes, yes. This was really why we got into why we developed this, because we were starting to work with customers that really were doing system engineering. They weren't just doing software. And so we wanted to use a lot of the principles and so forth that were in SAFe, but we wanted to do it with system engineering. So yes, these things do apply to the those that are developing software and hardware together in parallel and so forth.
Is there a big block in there somewhere where you actually focus on hardware, software, and firmware trade-offs?
Yes, there is. And so that would, to me, that's really where you are moving from the analysis aspect to the design aspect. So that is where you're doing these trade-off studies on how do you want to take it down to the next level. Analysis, you probably really don't need to know exactly, in most cases, whether you're going to be doing hardware, software, firmware, whatever. You're just going to be providing these things. And then when you get to the design, now you have to start making the trade-off decisions. Are we going to go the hardware route with this? Are we going to go the software route with this? Or what? And so it's at that point where you're planning for the next program increment that you're taking this segment of the roadmap, and now you're going to have to make those decisions so that the teams, when they get into the program increment, can implement the right things. So they can implement by building hardware, they can implement by building software, they can implement by doing firmware, whatever. So that's where that happens.
Okay, thank you. And Sheila Dias is out there. I think she's still on. Sheila, do you want to ask your question, or?
Sure. I was wondering if there's a minimum size program, for software. It's usually just FTEs for utilizing SAFe.
For utilizing SAFe,
Yeah,
typically the folks at SAFe say, unless you have a team of approximately 60 to 70 people, that's about the minimum size for SAFe. Otherwise, the overhead of doing what you need to do in SAFe is too high for what you're doing. But I've seen it work for anywhere from 60 to the largest one that I've been associated with had over 2,000 people, working within SAFe on a single program. But you get much below that, and you can have an Agile team or a couple of Agile teams, maybe 3 Agile teams working together, and they can work closely together, and they can accomplish a lot without having a lot of the overhead that's involved in SAFe that you need once you get teams of teams.
thank you.
Mm-hmm. How are we doing?
You have gone through the list, and Drezej complimented you and said thank you for your explanations to his questions.
Okay.
Good explanations. So throw it back open to the floor.
Mark, I'll try a question.
Okay, go ahead.
Where in this process, I can make some guesses, but like your input, where in this process is it that the systems engineering effort looks at the architecture to make sure that we don't go down a dead end architecture, that several iterations later, we end up that it won't work. Or there's a late change that we could have identified as a risk that in the past have caused things to go cattywampus on various architectures.
Okay, good question. So what you see is that at the beginning, I mean, just before you get into program increment planning, you are taking that look at the architecture. You're taking that look at where you are with the architecture and reviewing it again. And so every time you get to the beginning of a program increment, you're going to do just what you said, is to review it, make sure that we're not heading down the wrong path. Do we need to pivot, and go a different way, or that kind of thing? So it's basically, in safe terms, it's almost like every quarter of the year, 4 times a year, you're going to do that review of the architecture and to make sure that you're still going the right direction. Now, something could happen during that quarter that could cause you to change, and you need to be able to react to that. But if we stay right on track, every quarter we're going to review that.
Does that review go all the way to the end, to the full set of documented features, even though it's not in the current increment?
No. So the review does everything that came before it and what we're expected to do here. So that's, we're only looking ahead basically 1 quarter with that kind of thing.
So I could be in an architecture that I ought to be able to look at now that isn't going to get the full set of features.
I'm not sure what that question asked. So in other words, we have the overview of the whole set of features. We have the overview of that but now we're just slicing out a part of that to go deep on. So we do review the overview, but we don't review the details of anything but where we're going in the next PI.
Okay, but the architecture handle the overview.
Yes.
All right.
Okay.
Any further questions? Otherwise, have a pleasant evening, everyone.
All right. Thank you very much. Thanks for inviting me.
Thank you, Peter.
Thank you, Peter.